All right, folks, welcome to 3.4. We are going to talk about medians and altitudes and all kinds of other segments that are inside triangles. The only one we know of right now is a mid segment, the connection of two midpoints. But we're going to talk about four other segments that exist in triangles. Okay, we're going to talk about perpendicular bisectors and angle bisectors and their properties. And we're also going to identify properties of medians and altitudes. The main thing, we need to be able to recognize what these four different segments are in triangles. All right. So first up, let's talk about concurrent lines because we are going to know what point of concurrency means. A point of concurrency is when you have three or more lines that are intersecting to one common point. Okay, so this point right here is the point of concurrency. We have four lines actually intersecting, but you need at least three, not two, you need at least three or more. And the point of concurrency is where they all meet. So concurrent lines are when three or more lines intersect at the same point, and that point is called the point of concurrency. That's going to show up a few times in this lesson. So just real quick, let's identify which one of these has a point of concurrency. In A, I've got two lines intersecting for a point here, here, and here. There are not three lines intersecting to a single point, so it cannot be A. For B, I have one line, two line, and three lines intersecting at a common point, so B definitely has a point of concurrency. And in C, we have two lines intersecting here, two lines intersecting here, but no three lines intersecting, so not C. So B is the only one with a point of concurrency because it has to have at least three lines meeting at a common point. Okay, so point of concurrency, at least three lines. All right, let's go ahead and talk about some properties. So first off, what you are looking at are perpendicular bisectors in the top, and I'm going to highlight them red here. Okay, so a perpendicular bisector. First off, perpendicular. Oh, sorry, let me go backwards. Perpendicular means 90-degree angle. So when I have a line intersecting with another line and they're perpendicular, that means they form a 90-degree angle, a right angle. So when we see the word perpendicular, that means we have a line intersecting another line at a right angle. So that is a perpendicular line. Bisector means cutting in half. So it doesn't matter if you're talking about an angle or a segment or a line. So if I have a segment and I cut it in half, I use the markings for congruent. So this side is congruent to this side because of that marking right there. That's called a bisector. Okay, so if I have a red line and I cut it in half with a blue line, then the blue line is the bisector. Okay, the blue line is the bisector. If it makes a right angle and cuts it in half, then it is a perpendicular bisector. So all these segments here in red in the figure, those are all perpendicular bisectors. Okay, so from D to this side, it is a right angle and it's cutting it in half. So it's a perpendicular bisector. All right, A here comes here. That is also a perpendicular bisector. Okay, so it cuts the angle in half and it makes a right angle. Okay, so a perpendicular bisector is when you have forming a right angle and cutting the segment in half. Okay, that's super important to understand. All right, an angle bisector is when an angle is cut in half. So if I have any kind of angle and I take a blue line and I bisect the angle, that means I'm cutting the angle in half. So, the way we tell is that the two halves are congruent. So we have to mark the two angles congruent because that shows that it was cut in half. So in this figure down here, I'm going to do it in red. So this line right here is an angle bisector because this angle got cut into two congruent halves. Okay. I also have this. Oops, sorry. Let's try that again. Refresh. I also have this angle cutting in half. But I'm going to use double markings because they're not the same as the single marking ones. And I have this angle being cut in half, being bisected. So it's going to have a triple measure. All right, so these are all angle bisectors because all of them had angles that were cut in half. Okay, so make sure you understand perpendicular bisectors are when we are perpendicular to the perpendicular to the triangle side, and it cuts it in half. Okay, angle bisectors is it cuts the angle in half. All right, main thing you understand what the difference between those two things are. All right, let's move on. So these are just a couple things. You don't have to write them down. It's just basically saying that if you have perpendicular bisectors, so all these red lines are perpendicular bisectors because look, it has the midpoint symbols, the congruency symbol, so it was cut in half, and it has the right angle symbol. So it's both perpendicular and a bisector. So basically this is saying that the perpendicular bisector, the point of concurrency is the same distance from all the vertices. So P to A is congruent to P to B, which is also congruent to P to C. All right. Main thing you need to know from this slide is that when you have perpendicular bisectors all meeting at a point of concurrency, it's called the circumcenter. Okay, that's all you need to know. All right. You don't need to know anything else about this because we're going to talk about congruency later on. But the point of concurrency for perpendicular bisectors is a circumcenter. It's called a circumcenter. All right. The point of concurrency for angle bisectors. Okay, look, we have angle bisectors here. This is an angle bisector because it cut this angle into two congruent parts. This is an angle bisector because it cut this angle into two congruent parts. And this is an angle bisector because it cut the angle into two congruent parts. All right, when three angle bisectors all meet at a point of concurrency, it is called the incenter. Okay, so circumcenter is the point of concurrency for perpendicular bisectors. Incenter is the point of concurrency for angle bisectors. Okay, that's all you need to know from this slide. All right, and we're gonna have a slide near the end that's gonna summarize all these points of concurrency for all our different segments. All right, so far we need to be able to identify perpendicular bisectors and angle bisectors, and we need to know what their points of concurrency are called. Okay, so make sure that we understand all of that. All right. All right, so now let's talk about altitudes. Okay, so far we got perpendicular bisectors and angle bisectors. Now we're gonna talk about altitudes. All right, this long paragraph here is just the definition of it. Here's basically what you need to know. An altitude comes from a vertex, so it comes from one of the corners of a triangle, and it is perpendicular to the side opposite of that vertex. Okay, so QT, the segment QT, also my nickname, is an altitude. Okay, so it's perpendicular, but it's not a bisector. Okay, so it's just perpendicular, but it has to come from a vertex. Okay, it has to come from a vertex. All right, another altitude would be from a vertex R all the way to U. That also makes a right angle. So RU, having fun, RU is a altitude. And another altitude in this figure would be SN. So vertex S all the way to the perpendicular N. That is also an altitude. So these are three altitudes. There's always three altitudes in every triangle. All right, so make sure that you understand what an altitude is. And we also need to make sure we understand that the point of concurrency, which is the point V right here, is called the orthocenter. Okay, so we have all kinds of different names for points of concurrency depending on the segment. So orthocenter is the point of concurrency for all altitudes, All right, let's check out medians now. Okay, so medians, a little bit different than altitudes, but similar in the fact that it starts at a vertex, but its other endpoint is a midpoint. It's a bisector. Okay, so look at where we have a midpoint. The reason why M is a midpoint is because it cuts the segment BC in half. Okay, so it's from a vertex to a midpoint. Vertex to a midpoint. So AM is a median. All right, another median starts at a vertex C and goes to the midpoint X. So CX is also a median. And starting at the vertex B and going to the midpoint L is also a median. So starting from a vertex and going to a median. Now it doesn't have to be in that order. I could have said MA, XC, or LB, doesn't matter. Because segments, it doesn't matter the order, as long as the endpoints are the two letters. So those are all medians, and the point of concurrency of all medians is called the centroid. All right, so point D is the centroid in this figure. All right, so altitudes, vertex to a right angle, medians, vertex to a midpoint. All right, and then we also have the points of concurrency, orthocenter for altitudes and centroids for medians. All right, so we've got all four of those segments: angle bisectors, perpendicular bisectors, altitudes, and medians. Let's summarize all of this. So here we go. We've got perpendicular bisectors. Remember, they have to be perpendicular and midpoints. I should probably say that. Okay, and it cuts it in half. So perpendicular and cutting in half, perpendicular and cutting in half. Okay, those are perpendicular bisectors. And the point of concurrency is called the circumcenter. Angle bisectors cut angles in half. Okay, it doesn't matter where they end up as long as they cut angles in half. All right, 3 different angles, so 3 different markings. And the point of concurrency for angle bisectors is called the in-center. Medians, from a vertex to a midpoint. Okay, we know it's a midpoint because of these congruency markings. So median, vertex to a midpoint. The point of concurrency is called the centroid. Altitudes are from a vertex to a right angle. Okay, make sure you understand that. Vertex to a right angle. And the point of concurrency is the orthocenter. And this is just a review from 3.3. Mid segments are when you have 2 midpoints that are connected to each other. Okay, so DE is the mid segment. All right, so know all 5 of these segments that exist in triangles. Okay, you need to be able to identify them. You need to be able to draw them. Remember, when you draw them, you have to put the evidence. So if it is a median, you have to put the midpoint symbols to show me that it is a midpoint. If it is an altitude, you have to put the right angle to show me that it is perpendicular. All right, got to put the evidence. If it's an angle bisector, put the angle bisecting symbols, the congruent angle symbols. All right, the notation is imperative. All right, so we've summarized all 5 of our segments that we know in triangles. Let's now identify them. So looking at evidence. All right, AB, is it a median, altitude, both, or neither? Okay, so number 1, I see a right angle. So right off the bat, that tells me altitude. Let's rule out median though. Median means it has to be a midpoint. Since this has a distance of 3 and this has a distance of 3.2, they are not congruent. So this side is not the same as this side, which means B is not a midpoint. So it is not a median. So it cannot be both. And since it is an altitude, it cannot be neither. So this is an altitude. Let's type it so it's faster. All right. Number 2, is it a median, altitude, both, or neither? So first off, I do not see a right angle where it is intersecting at B, so it does not have an altitude, which means it cannot be both. Let's check for median. Median means it has to be a midpoint. This is a midpoint because these 2 congruency markings. That means B, cut it in half. B is a midpoint. So midpoint means it does have a median. So median is our answer for number 2. All right, so you gotta be able to identify it based on evidence, not what you think it looks like, based on the evidence. All right, let's try 3 more questions like this. Okay, median, altitude, both, or neither. So here we go. So number 3, I see a right angle. So that tells me altitude. And I do not see a midpoint, so it is not median. So it's not both and it's not neither, but it is an altitude. So number 3 is an altitude. All right, number 4. I see B is here. There's no right angle, so it's not an altitude. There is no evidence of it being a midpoint. Okay, we could guess it is, but there's no evidence of it being one, so it's not a median either. So this is neither. It is not a median nor an altitude. But what is it? If we had to identify what it is, what is it? This is an angle bisector because it is cutting an angle in half. Angle A was cut in half, so that is an angle bisector. But to answer the question, it's neither a median or altitude. But if we had to identify it, we would call it an angle bisector. All right, number 5, we have B is a right angle. It's forming a right angle, so it is an altitude. And we know that this segment is 7 and this segment is 7. That means that these two segments are congruent, which makes B a midpoint, meaning we have a median as well. So we have both a median and an altitude. So both to answer this question, but if I had to identify what it was, that is a perpendicular bisector. So a perpendicular bisector means it is both a median and an altitude, okay? So perpendicular bisector and angle bisector for 4 and 5, okay? Make sure you understand the difference, all right? So that's how you identify all of our segments. The last thing we're gonna talk about is the concurrency of medians theorem. So right now we are only focused on medians, okay? Only focused on medians. So all of these red segments here are all medians because we see midpoints, okay? H is a midpoint, J is a midpoint, G is a midpoint. So we have 3 segments that all meet some midpoints. So we're talking about medians. What this is saying is if I go to the point of concurrency, this distance is twice the length of this distance. So here, let me actually use different colors here. So from D to the point of concurrency is double the distance from J to the point of concurrency. So from the midpoint to the center point of concurrency is half the distance of this one. So for example, let's say this entire thing, well, no, let's just make it even simpler than that. Let's say this distance was 10. Let's say from J to C was 10. Since J to C is 10, that means from C to D is double that distance. So this would have to be 20, and that makes the entire distance from J to D 30, okay? So from the midpoint to the point of concurrency is half the distance the rest of that median, okay? So let's look at another example. Let's look at EG. Let's say I know that EG, oh, that's an eraser. Let's actually draw it. Let's say that the segment EG, the median EG, has a distance of 45. The whole thing, the whole median is 45. And I do know that from the midpoint to this point of concurrency is just a single X. And from the vertex to the point of concurrency is a double X. It's twice the distance as from the midpoint to the point of concurrency. So if I know that 45 is the total distance, this is an algebra question. X segment plus the 2X segment equals the whole median 45. So that means 3X equals 45. We want to find the value of X here. All right, so if I divide by 3, my X value is 15. So now that I know the X value, I can find the length of GC and I can find the length of EC. So let's just do the length of GC. GC is just X, so that means GC is 15. Then I have the length of EC, which is double the length of GC. That should be 30. All right, 2 times 15 is 30. So that means the whole distance is 45, and we have 15 from the midpoint to the center, the point of concurrency, and 30 from the vertex to the center. All right, let's apply this theorem to some questions here. All right, if XA is 8, find the length of XB. So let's find XA. XA is this distance right here. So XA is from the vertex to the point of concurrency. So this is the 2X length. And from the midpoint to the point of concurrency is the single X length. All right, so what do we know? We know that XA is 8. So this 2X side is 8. So if 2X equals 8, what is half of that? All right, you can do algebra if you want to, or you can just look at, well, double the value of X is 8. So what is single the value of X? So divide by 2, this is the algebra way to do it. We get a value of 4. So the length of XB is 4. Oh, no, sorry. The length of AB is 4. The length of AB is 4. The question is XB. Sorry, always read the question. Make sure you know that question. All right, so the AB is 4. What is the length of the entire median from X to B? Now that we know both, we add the 8 and the 4 together to get 12. So the length of XB is 12. All right, let's go ahead and try number 2. For number 2, we have CZ. So from the entire length of the median, C to Z, we have a length of 15. Find the length of AZ. So from A to Z, that's the double length. That's the 2x length. And from C to A, that's the single x length. And we know 3 x's gives us 15. So we're going to go ahead and find the value of x first. So 3 total x's from C to Z has a length of 15. And we want to know the length of a single x. So we divide by 3, and we get x is equal to 5. So I know x is equal to 5, so that means C to A is 5, and Z to A is twice that, so it's 10. The question is, what is AZ? AZ has a length of 10. All right, last question of the lesson. We have some information on XB. So XB is the entire median. So from X to B has a length of 30. We know that from X to A is twice the distance. And from B to A is just a single x distance. So we want to know, what does x equal? So a little bit of algebra again. The total distance of 3 x's is 30. So to find out a single x, we divide by 3, and we get an x value of 10. So that means from A to B, we have a single x value of 10. And from A to X, we have a double x value of 20. We know all the information, so let's answer the question. What is the length of AB? AB is 10. All right, so that is how we use the medians in terms of the point of concurrency. Okay, so from the vertex to the point of concurrency is double, and from the midpoint to the point of concurrency is half. All right, so you have a homework assignment for 3.4. Let me know if you guys have any questions. Have a good day.